Okay, so again, you will have 8 questions on your Chapter 2 test. I'm going to break down each of them. And what I'll go ahead and do is I'm going to, like, in this pink marker, I'll put, like, what section you can find it referenced in the corner here. So our first problem, you're going to have one problem that's referenced in Section 1. Okay, Chapter 2, Section 1. You're going to have one problem from this. And it's going to ask you, now, Section 1, just to remind you, Section 1 dealt with adding and subtracting polynomials. Adding and subtracting polynomials. So this will be similar to what you'll be asked to do. You're going to be asked to add or subtract 2 different polynomials, and then you're going to be asked to do a couple of things. First, you're going to be asked to write it in standard form. Then you're going to be asked to identify the degree of that resulting polynomial. And finally, you're going to be asked to identify the leading coefficient of that polynomial. All things that are defined in Section 1. Okay, so this is an example of what you'll see. Okay, 2x cubed minus 5x squared plus x minus, you will get a subtraction problem tomorrow, I'll tell you that right now. 2x squared plus x cubed minus 1. Sorry, I got a little crowded in there. Okay, so again, I will tell you, you will get a subtraction problem tomorrow. It could be either addition or subtraction, but I will tell you it'll be subtraction tomorrow. So we're asked to subtract these 2 polynomials from each other. So in your margins, if you want to give yourself little notes and hints and stuff like that, the basic premise here for Section 1 is that I'm going to be combining like terms. Okay, again, if you need that in your margin, you're combining like terms. It's basically the only way we can add and subtract polynomials. In other words, x cubed can only go with other x cubeds, right? X squareds can only go with other x squareds. X's can only combine with other x's, of which there's only the 1 in here, so that will end up staying the same. And numbers will only be able to combine with other numbers, combining like terms. So the fact that we're dealing with subtraction, one thing I want to point out here, and this is my general suggestion, if I'm subtracting a parentheses, another way to think about that is that I'm multiplying a -1 times this whole thing. So here's my suggestion. Rewrite this subtracted polynomial with all of its signs flipped. That will be the equivalent of subtracting it. So for instance, since this polynomial came first and order matters in subtraction, nothing will technically happen to this guy. It'll stay 2x cubed minus 5x squared plus x. But then when I subtract positive 2x squared, that's just the same thing as saying minus 2x squared. When I subtract the positive x cubed, that's like minus x cubed. And when I subtract a -1, that's the same thing as saying plus 1. So technically what I did is I just changed each sign there when I subtracted it. That's my suggestion. That will avoid some of the confusion that happens when I subtract the parentheses. Okay, flip the sign of every sign in the subtracted parentheses. Another thing I want to point out here, this was on purpose. These 2 are technically not in order, or what we would call descending order. You'll notice that the squared came before the x to the 3rd power. One thing that you're going to be asked to ultimately do in this case is to rewrite your result, whatever I get when I combine like terms, rewrite my result in standard form. So just to remind you, it's defined in Section 1. Standard form means that literally it's going to work from highest exponent down to lowest exponent. Okay. So we're not going to really run into that problem here just based on how it's organized in the front, but be aware that's something that you'll be asked to do. So anyway, let me jump back into the problem. So at this point, I just have one long string polynomial. My job here is to combine like terms. So x cubed can only go with other x cubed. So in this case, x cubed can only combine with this x cubed. Okay. And notice I kept the sign in front of it. So when I have a positive 2x cubed combined with a negative x cubed, my result here will be just a single or 1x cubed. All right. X squareds can only go with other x squareds. So this -5x squared can only combine with this -2x squared. And so when I combine these guys, -5 and -2, that will make a -7x squared. X's can only combine with other X's. Well, there are no other X's to combine with, so that plus X stays just plus X. And lastly, numbers can only combine with other numbers, so this plus 1 will remain plus 1. And this would be my final answer for the arithmetic happening here, namely just subtracting the two polynomials. So another thing I want to point out at this point, and I'm doing this on purpose because be aware that this might happen on your test tomorrow, hint, hint, right? That you may end up with something that's out of order. Technically, I can rearrange any of these single terms in any whichever way I want, as long as I keep the correct sign with them, okay? Now, be aware that in order to write this in standard form, it has to be in descending order where the highest exponent comes first and it works its way down from there. This one is already in standard form. So this one is done as far as that goes. But be aware, if it is jumbled up in any way, shape, or form, reworking it into standard form means putting it in descending order for the exponents. So at this point, be aware on your test tomorrow, you're going to be asked to do a couple of things. First, it's going to ask you to write it in standard form. Okay, this one already is in standard form. So what does it mean in case it's not? It means descending order for the exponent. Write it in descending order in terms of the exponent. Highest exponent first, lowest exponent at the end. Numbers technically have the lowest exponent. The second thing you're going to be asked for will be the degree of that function, of that result that you get. So in other words, it's asking about the degree of my answer. So I'll remind you, this is in section 1, but the degree of this entire polynomial just is going to be the highest exponent value. In this case, it's a third degree polynomial. So degree here, 3. Where did the 3 come from? It's the highest exponent in my result. And the last thing you'll be asked about here will be the leading coefficient. A coefficient, I'll remind you, just means the coefficient is just a number value that's multiplied by a variable, okay? So the coefficients are basically the numbers that are in front of the letters in this case. So in this case, the leading coefficient, once you rearrange it in standard form, the leading coefficient should be the highest exponent value. The leading coefficient is what number is multiplied in front of the highest degree term. Technically, even though there's nothing written here, technically there is a number here. That number just is 1. So in this case, the leading coefficient is 1. So even if there's nothing written, like in this case, there's still a number technically there. Other cases, it'll be more obvious where there is a number in front. In that case, you just copy the number. So for the record, this is really where the most points will be coming from, is doing the arithmetic and getting to your ultimate response. Each of these will be a single point because it's just identifying something. Okay, standard form takes a little bit of rearranging into descending order, but degree and leading coefficient simply come from this first term. Degree being the highest exponent, leading coefficient being the number that's multiplied in front. All right, that'll be your section 1 problem. Let me move on. All right, you're going to have 2 questions from section 2. 2 questions from section 2. So this will be under the headline of chapter 2, section 2. In section 2, we dealt with multiplying polynomials. Multiplying polynomials. This will end up being the inverse of factoring, which we do in the second half of this unit. But in this case, you're going to be given the following instructions. Find the product. Product is the fancy math way of saying multiply and see what your answer is. Okay, so we're going to be asked to find the product of the following. And so you'll be given some polynomial to multiply. And so in this case, we'll start with something a little more basic. What you'll see on your test tomorrow, you'll be given a simple binomial times binomial, like this. So again, what does it mean to find the product? Product means multiplication. There's multiplication happening here in the middle. So again, if you're writing stuff down in your margins off to the side, little hints to yourself, multiplying polynomials basically breaks down into a 2-step process. Step number 1, distribute. Okay, distribute. We distribute through multiplication. So I'm taking each object and multiplying it through the parentheses. Okay, so step 1, distribute. Step number 2, once I have distributed, collect any like terms. Okay, step 1, distribute. Step 2, collect like terms. That's how we're going to multiply polynomials. And so in this case, Again, I'll remind you that we're multiplying these two guys. And so the way to multiply polynomials is that I go object by object. So my first object here is just x. And because it's multiplying through this parentheses, I'm going to first multiply that x through this parentheses. So x times x gives me an x squared. That same x times -5 gives me -5x. And I'm done with the x. Move on to the next object. +2 times x. If this +2 is going to multiply through this parentheses as well. So +2 times x gives me a +2x. And lastly, the +2 times -5 gives me -10. There's our distribution. Okay, step one, distribute. Through multiplication, this is the long polynomial that we got as a result. Step number two, collect any like terms. X squareds can only go with x squareds, x's can only go with other x's, and numbers will go with numbers. All right, so this is actually similar at this point to what we did in the first problem where I'm just collecting like terms. Okay, and in this case, only these x's can combine, right? So the -5x, and that I do this on purpose with keeping the signs with the numbers. Okay, the -5x and the +2x will combine. X squared, there's nothing like it, so x squared stays x squared. The -5x plus 2x gives me -3x. You're allowed a calculator, so if you need to, you can always fall back on that. And the -10 can't combine with anything, so it stays -10. And there is my last result. Okay, again, distribute, collect like terms. All right, let's keep going. So that one was on the simpler end of the spectrum. You're also going to get one that will be a little bit longer, same technique, but a little bit longer. So in this next problem, again, like I said, you're going to have two problems from section 2. This is the second of those. You're going to have something a little bit longer. Same technique though. Okay. In this case, it's going to be a binomial times a 3-term trinomial. But you're going to be asked to do the same thing. Find the product. Product again being multiplying. I'm still multiplying these two things, and it's still going to be the same process. Number one, distribute. Number two, collect any like terms. So this first object, this x, is going to be multiplied throughout this parentheses. And then once I'm done with the x, then I'm going to take the +5 and also multiply it through the trinomial. And then I'll have some result. I'll collect any like terms. So let's go through that now. X times x squared. That gives me 3x's, or x cubed. X times the -3x gives me -3x squared. And lastly, the x times -2 gives me -2x. Done with the x, move on to the next object, the +5. +5 times x squared gives me +5x squared. +5 times -3x gives me -15x. And lastly, +5 times -2 gives me a -10 squished in here at the end. Okay, so there's the process of distribution. This one just happens to be a little bit longer, but nothing really changed as far as the technique. Okay, and it's longer because I have a longer polynomial that I'm multiplying through. Okay, but there's my distribution. So step one done. Step two, collect any like terms here. I actually end up with two different types of like terms, but let's make our way down the line. X cubed can only go with other x cubeds. It's the only one here, so my result is just going to have an x cubed. X squareds can only go with other x squareds. Well, I have another one right here, so my like terms would be this -3x squared and this +5x squared. And so when I combine these two, -3 and +5, I get a +2x squared. All right, done with the x squareds. X's can only go with other x's. So this -2x can only combine with this -15x. All right, so -2 and -15 will give me -17x. And numbers can only go with other numbers, so this -10 is the only one of its kind, so the -10 stays -10. And there is my result for that distribution and collection of like terms. Same process, just slightly longer in this case. Okay, let's keep going. All right, we're going to do two problems from section 4. Now I'm skipping section 3 on purpose. Section 3 had to do with special products. So those were like what happens if I have a polynomial times itself or a polynomial squared and stuff, but that's really no different than what we just did. So you're going to have two problems from section 4. Section 4 had to do with solving polynomials. So your instructions are going to be a little bit different, and that's going to tell you to solve. What's implied with solving? Solving literally means I'm going to be dealing with equations. In other words, this will be slightly different in its structure, and then I'm going to have an equal sign, which also means that I'm going to be able to have x equals some value as my actual answer. So in section 4, we're dealing with solving. Okay, so our first problem will be a little bit more on the basic end of the spectrum. We're given this factored polynomial. And again, the distinguishing factor being the fact that we're dealing with an equals sign now. Again, this equal sign literally implies that I'll be able to isolate an x and get actual solutions. Okay, so this is a factored polynomial. I know it's factored because it's into these, technically this as it is a single monomial. Okay, because I have an object times an object times an object. This is all technically one object. Okay, this is a monomial now, but it is a factored form of a greater polynomial. Okay, and again, I can tell factored things because they have these parentheses. That's another dead giveaway. So this process, what we learned in section 4, dealt with the zero product property. Okay, now the name itself won't really help you, but as far as like what note you could write to yourself in the margins and stuff, zero product property basically told us this. In a string of multiplication, and I'm basically multiplying 3 different things in this problem. In a string of multiplication, if any one of the things is 0, it doesn't matter what the other things are, the whole product will end up being 0. So your note to give yourself in the sideline here, okay? Make sure that you first factor your polynomial. Actually, let me back up a second. Technically, step number 1, if you're writing down the margin, is first make sure you're set equal to 0. In our next example, we're going to deal with something where I first have to deal with moving it to equal 0 first. So in this case, I didn't have to do anything with that. But step 1 in your margins, make sure your equation equals 0. So anytime you're told to solve, make sure you're equal to 0. Okay? In order to use the zero product property, I need this to be true. So step 1, set the whole thing equal to 0. That was already done for us, so we didn't have to do anything with that. Step 2, factor your polynomial. Okay. In our next example, we're going to deal with an unfactored one. So we first need to move it into this factored form in order to make it more simply solved. This one, again, already done for us. So step 1 and 2 were already done for us here. So again, step 1, set equal to 0. Step 2, factor your polynomial. This one was already factored because I see the parentheses. Okay. Step 3, now I'm going to take each of the multiplied objects and set each of them equal to 0. So in this case, my first multiplied object, 2x here, take 2x, set it equal to 0. My next multiplied object, x minus 4, take that, set it equal to 0. My last multiplied object here, x plus 1, set it equal to 0. Why did I go through this process? Why did I set each of these multiplied objects equal to 0? Because if 2x equals 0, then it doesn't matter what both these parentheses are. 0 times that string will end up being 0. If x minus 4, this parentheses, if that turns out to be 0, it doesn't matter what these two guys are. The whole thing multiplied together will give me 0. And the same applies for the last guy. Set each multiplied object equal to 0. And now what you're going to have is you're going to have a bunch of one-step solution problems. Okay. In this case, if I want to solve for x, I would have to move this 2. This 2 would move by division. Divide both sides by 2. 0 divided by 2. I'm going to get x equals 0. In this one, in order to get x by itself, I would add 4 to both sides. So x equals positive 4. In this one, I would subtract 1 from both sides. And that's going to give me x equal negative 1. These are the 3 possible solutions. As I said, when it asks me to solve, I'm going to get x equals some value. The fact that I have 3 different possible values has to do with the fact that if I were to plug any of these 3 values in, I'll get a true statement. So if x equals 0, and I plug 0 in for x, 2 times 0, well, that's 0. Then it actually doesn't matter what these two parentheses are. 0 times those, they're going to give me 0. And the same is going to apply for 4 when I plug it in here. And the same is going to apply for -1 when I plug it in here. There's a zero product property in effect. All right, let's move on. Again, this would be my solution here. All right, our second problem from section 4, you're going to be asked to do the same thing. You're going to be asked to solve, but now we're going to be given something a little bit different. So in this case, we're given this polynomial, x squared plus 4x equals 21. Now already you can see there are some similarities and differences with the last problem. First off, our similarities, I still have an equal sign. And that makes sense because if I'm asked to solve, I'm going to get x equals some value. But after that, you see some differences. First off, I don't see any parentheses. This is unfactored. And also the second thing is that it's not set equal to 0. So again, just like I told you to write in the margin for your section 4 problem last time, we're going to follow the same process. Step number 1, rearrange your equation so that it equals 0. Now, there are a couple ways I could attack that. I could take these guys and move them over here to the right, or I could take this guy and move it over to the left. Well, since I only have to move one object, let's move this guy to the left. Again, because my first step here is to rearrange my equation so it equals 0. So how do I move this 21? Because it's a positive 21, I'm going to subtract it from both sides. Okay, and over here on the right, what's going to end up happening, 21 minus 21, the whole reason I did it was now it's going to equal 0. Again, the priority of my first step, set my equation equal to 0. So over here on the left-hand side, 21 is actually not going to be able to combine with either the x squared or the x. They're not like terms. And so the x squared and the 4x stay exactly the same. But when I subtract 21 from it, it's not able to combine. So it's written just at the tag end right there, x squared plus 4x minus 21. Step number 1, when I'm asked to solve, step number 1, set your equation equal to 0. Step number 2, make sure your polynomial is factored. This is an unfactored polynomial, unlike the last problem that we dealt with. So in this case, we're actually going to use another concept. So what I'm going to go ahead and add in the margin here is that not only are we using a section 4 strategy of solving, but we're also going to be using section 5 for this next part, for the factoring part. In section 5, we learned how to factor an x squared trinomial. Okay, the actual title of it was x squared plus bx plus c. Okay, but we learned how to factor this. And the punchline here is that for section 5, I'm basically just asking myself the riddle. What two numbers will multiply to make the last value that also add together to give me the middle value? Okay, it was section 6 where we did the x method. It's not necessary here because it's just x squared in front of the polynomial. So I don't have to, because there's not a number, not another number other than 1. Technically there is a number, it's just 1. But if there was some other number in front of x squared here, I would have to use x method. Because there's nothing there, or namely there is something, it's just 1, I can jump right to my riddle. Okay, and so for this, what two values will multiply to make 21 that also add to make 4? Okay, and so I'll go ahead and show a little bit of that work right now. Some of you still kind of need this. I always say start with what I need to multiply because there's fewer options. So in this case, what are the things that multiply to make 21? Well, 1 and 21 and 3 and 7. And that's actually it. Those are my only two options. Okay, so of these options, the things that multiply to make 21, can I combine them in some way to make 4? Well, 1 and 21, I cannot. They're too far apart. 1 and 21, there's no way I can combine them to get to 4. 1 plus 21, 1 minus 21, 21 minus 1. There's no combination. 3 and 7, I can combine in some way to get to 4. Namely, if I subtract 3 from 7. Addition or subtraction, I can combine 3 and 7. So this will end up being the answer to my riddle. But again, because I'm trying to get to 4, I would have to subtract 3 from 7. And that tracks because, again, if I multiply these two together, I want a negative 21. So a negative 3 times 7 will give me the negative 21, and negative 3 plus 7 will give me the positive 4. So this is the answer to my riddle. So what do I do with these two values? So again, for this part, for step 2 of this whole process of I need to factor this polynomial, what I'm going to end up with here when I factor this polynomial is a parentheses times a parentheses, and it's still going to be equal to 0. And what we learned in section 5 is that because my first term is x squared, the first object in each of these parentheses is going to be x. And that makes sense because if I were to redistribute this, x times x will get me right back to x squared. So really all I have to do is answer the riddle and figure out what these two objects are. And the answer to that was the answer to the riddle, -3, +7. Doesn't matter which one goes where. So I'll just go ahead and put the -3 first, +7 second. And there's the factored form of that trinomial. Again, I could get away with just asking the riddle because it was just x squared. We're going to do an example in a little bit where we are dealing with something where there's not just an x squared there. But so back to our original question, just to keep us on track. Step number 1, rework your equation so that it equals 0. Step number 2, factor your polynomial, because now I can apply the zero product property, just like we did in the last problem. So at this point, what I'm going to do is now I'm going to set each of my multiplied objects equal to 0. So technically this is step 3. This is the step that we basically started with in the last problem because it was already factored, it was already set equal to 0. So in this case, each of my multiplied objects, in this case I only have 2 multiplied objects, I'm going to set each object equal to 0. So x minus 3 equals 0, because if this is true, if x minus 3 equals 0, it doesn't matter what happens here. 0 times that something equals 0. And conversely, x plus 7, my second object, is also going to be set equal to 0 because, again, if that equals 0, it doesn't matter what this parentheses was. 0 times that something equals 0. And as you can see, just like in the last problem, these are both one-step solutions. In order to get x by itself in this one, I would add 3 to both sides. And so I get x equals +3. For this one, in order to get x by itself, I would subtract 7 from both sides, and I would get x equals -7. And those are my 2 solutions. So again, just breaking down the process, step 1, set your equation equal to 0. Step 2, factor your polynomial. Step 3, now set each multiplied object equal to 0. All right, let's move on. All right, we're going to do one problem from section 6. One problem from section 6. So section 6, to break it down, section 6 was like, all right, now factor a trinomial where it's not just x squared. It's some number multiplied by x squared. So in this case, we're given these instructions. Factor. This was an element of the last couple problems, but this will be the highlight of this problem that you'll have in your test tomorrow. So you're going to be given a polynomial. In this case, 4x squared plus 13x plus 3. And you're simply going to be told to factor. Now this actually goes back to yesterday's notes. In yesterday's notes, I gave you a little checklist. Anytime your instruction is to factor, do this checklist. Step number 1, always check if there's something in common between each of your terms. I have 3 terms here. Looking at the numbers, 4, 13, and 3, there's nothing in common. The only thing in common would be 1, and that's not worth factoring out. From the letters perspective, my variables, x squared, x, this one doesn't have an x, so there's no variable in common either. In other words, I'm stuck with this for the time being. So step 1, always check. When I'm asked to factor, step 1, check to see if there's a greatest common factor. So again, in your margin, if you're doing those extra notes, if I'm asked to factor, step 1, look for my GCF, my greatest common factor. I don't have one, so now I can move on to step 2. And again, this goes back to our checklist from yesterday. When I'm asked to factor, after I check if there's a greatest common factor, step 2 is to determine how many terms are there. Well, I have 3 here. Why did that matter? Because now determining how many terms there are, I figure out what strategy I use to factor. In this case, there are 3 terms. I have one of a couple options. Either one, I jump right to my riddle, what numbers multiply to make the last, that also add to the middle, or I have to use X method. In this case, I have to use X method. Why? Because it's not just x squared here. It's 4 times x squared. This extra coefficient here, the fact that I couldn't factor it out at the beginning, I have to use X method. So let me do that really quickly. X method. There's my X. Here's my table. All right. So top of my X, that's going to be my first term times my last term. 4x squared times +3 gives me a 12x squared. Bottom of my x, that's my middle term, positive 13x. Just don't forget about the sign that's attached to your coefficient. And here's where I ask the riddle. What two numbers will multiply to make the top that also add to make the bottom? So I always say start with what you're doing with multiplication. There are a few things that multiply to make 12, so many of you can figure out what you're doing already, but let me go through that list anyway. 1 and 12 will multiply to make 12. 2 and 6 will multiply to make 12. 3 and 4 will multiply to make 12. And that's it. Okay, of my whole numbers. Those are my combinations. So those numbers will multiply to make this top number. I'm looking for a combination that will add to make positive 13. Okay, 3 and 4, I can't combine those in any way to get big enough to get to 13. 2 and 6, same deal. I can't get to 13. 1 and 12, however, if I add those two, I can get to 13. So that's the answer to my riddle. 1 times 12 gives me 12. 1 plus 12 gives me 13. So positive 1, positive 12. There's the answer to my riddle. Add in my variable, the x. These will end up being in the diagonals in my table, but top left box of my table is the first term, 4x squared. The last term is going to end up being this bottom right box, this positive 3. And then the diagonals of my box will end up being the answer to my riddle. And it doesn't matter which one goes where. Okay, so positive 1x or just positive x, and then the positive 12x. Okay. For the record, what we're doing at this point, this is actually grouping. This is what we covered in section 8. Grouping is essentially making my groups of things and looking for common factors. That's essentially what I'm doing here with columns and rows. Okay, just as a little side note. But at this point, now what I'm looking for are common factors for both my columns and both my rows. So I always start here with my first column, 4x squared and positive x. Okay, technically there's a coefficient here of 1, so 4 and 1. The only thing in common is 1. But then an x squared and an x, they do have an x in common. That's the only thing in common in that first column. Second column, 12x and 3. No letter in common here, but 12 and 3, I do have a common factor of positive 3. Okay. First row, I could look for a common factor here, or I could ask the question, x times this something will give me 4x squared. In either case, I get 4x as the result. Okay. In this row, again, I could look for a common factor, or again, I could ask the question, x times this something will give me this value, and that something in this case will be a positive 1. Okay. I could double check seeing by multiplying columns and rows to find out and fill out this table. Okay. So these will end up becoming my factors. They'll be my parentheses. And so my last answer here will be x and positive 3 or x plus 3. And it actually doesn't matter which one of these I put first or last. My last one, 4x and positive 1 or 4x plus 1. There are my common factors. Again, the whole reason we do that table thing, that's actually grouping. Okay. But there's my final answer. This is the fully factored version of my original polynomial. Again, using X method. I had to use X method because of that coefficient. This can be found in section 6. All right, let's move on. All right, this next problem is actually going to combine two different sections. All right, section 7. Section 7 had to do with special factoring products, but also we're going to use section 8 for this problem. Section 8 had to do with factoring completely. Factoring completely. In other words, this one's going to be a multiple step factoring problem. So you're going to be given the same instructions as the last problem. You're going to be told to factor, so we're still going to have to use that checklist. Okay. And here is an example of what you might see. This will actually be very familiar. We only did this a couple of days ago. Okay. Actually, I think we did it yesterday. All right. But here we're given this two-term polynomial, and we're asked simply to factor it. We're going to use both of these sections in order to attack this problem. So as I said before, anytime I'm told to factor, this is basically going to break down to a two-step process. Step number 1, pull out any greatest common factor in here. Do both these terms, there are only two terms, so do both these terms have something in common? Start with my numbers, 7 and negative 28. 7 can go into both those numbers. Now my variables, my letters, x to the 4th, x squared. Both of them have two x's in common, or x squared in common. So 7x squared will ultimately be my greatest common factor that can go into both of these terms. When I pull out a greatest common factor, I'm doing it through division. Okay, so to figure out what's left over, once I pulled the 7x squared out, I'm basically dividing 7x to the fourth divided by 7x squared and the negative 28x squared divided by 7x squared. Okay, so another way to attack it again, deal with your numbers first. So if I want to figure out what's left over for my first term, 7 divided by 7 gives me 1. And the x to the fourth divided by x squared leaves me with x squared left over. 1x squared technically, but I don't bother writing the 1. I can confirm that I did that correctly because if I were to multiply these two back together, I should get right back here. And for my last term right here, when I factor out 7x squared, if I take this negative 28 and divide it by 7, I get negative 4. And then the x squared divided by x squared ends up canceling, so there's no x that I have to worry about there. And so there's my factored version of greatest common factor. But again, section 8 concept, I need to make sure I can't keep going. This turns out to be a difference of squares. In other words, it's still factorable. Okay, just because I pull out this greatest common factor first doesn't mean I'm done. That just means that now I'm checking to see is there anything left I can do here. So again, step number 1, pull out a greatest common factor. Step number 2, how many terms am I dealing with? Okay, I'm dealing with 2 terms. And according to my checklist, that means I'm looking for one specific type of scenario. Is it a difference of squares? How can I tell? The difference part deals with subtraction, so that checks out. And the squares part means, can I take the square root of both of these terms? The answer is yes. I can take the square root of x squared, that'll give me x. I can take the square root of 4, that'll give me 2. Okay, so this can factor further. So what will that mean? So the 7x squared, that nothing happened to that, that's still there. But when I factor this x squared minus 4, I'm going to get 2 parentheses. Okay, and this is where we applied that structure that we learned for difference of squares, the process that we learned in section 7. Okay, anytime I'm factoring a difference of squares, I'm going to get a sum difference combo. Okay, sum and difference combo. And in this case, now I'm looking for what goes in these first positions. That's going to be the square root of my first term, and then the square root of my second term is going to be my second combo. So here's a little bit of work on that. Square root of x squared is the first term. That's going to give me x. Square root of my second term, 4. That's going to give me 2. Those values are right there are going to be what goes into each of my spots. This first spot is going to be the square root of my first term. That's going to be x in both spots. Square root of my second term is what goes into the second position, 2. And that is the final factored version of this form. So please make sure you're factoring it completely. That comes from section 8. All right, one last problem. We're going to be asked to factor again. This one will pretty much exclusively be section 7. Or sorry, section 8. This is the last thing that we learned, and that was we're going to be using grouping for 4-term polynomials. So here's our last example. X cubed plus 3x squared plus 2x plus 6. Okay, again, we're asked to factor. So step number 1, check to see if I have a common term between any of my terms. I have 4 I'm dealing with here. So numbers 1, 3, 2, 6. There's no coefficient in common, so I can't do anything with that. Letters, x cubed, x squared, x, no x there. So I'm stuck with this as of now. So step 1, check for greatest common factor, done. Step 2, how many terms do I have? I have 4 terms. There's only one strategy I have for dealing with factoring 4 terms, and that's using grouping. Okay, so I'm going to use grouping at this point. This was from our first day in section 8. So in this case, what I'm going to do is I'm going to group the first 2 terms and then the second 2 terms together. So in this case, I'm going to have x cubed plus 3x squared. And then my second group, I'm going to have this 2x plus 6. And what I'm doing in each of these cases, in each of these groups, I'm looking to pull out a common factor. Right? So in this blue group, my common factor here, but the only thing in common is x squared. No numbers in common, but 2 x's are in common. And so when I pull out x squared from x cubed, I'm left with a single x left over. And when I pull x squared out of 3x squared, I'm just left with positive 3. All right, group 1 done. In this group, looking for my common factor, the only thing in common between those 2 terms is a positive 2. And when I divide 2 out, when I divide 2 out of 2x, I'm left with just x. When I divide 2 out of positive 6, I'm left with positive 3. This is what I'm looking for when it comes to grouping. When I do my grouping procedure, I want these parentheses to match, because since they do match, I can now factor out that parentheses. So that parentheses being x plus 3 is what I can factor out now. And now what's left over, when I divide this parentheses out of this first term, I'm left over with just x squared. And when I divide this x plus 3 parentheses out of this term, I'm left with just positive 2. This will end up being my final answer. Technically, I would check to see if I can factor this further. This is not a difference of squares. So this is my final answer in this case. There we go. All right, I'm going to stop recording. I know I went over. My apologies.